So yeah, let me do an example with significant figures, right? Can't find the mouse. So example, we have 195.8024. We want to write it to six significant figures. So we find where these six significant figures is 1, 2, 3, 4, 5, 6. The number after it is less than 5. So just like before, right? If the number is less than 5, we leave it alone. So the 195 point, sorry, 80802. And if you want to use the fancy equal sign is okay. 5 significant figures. Again, you count 1, 2, 3, 4, 5. The number after the 0 is less than 5, which the number is 2, is less than 5. So you leave the 0 alone, 195.80. But remember, the 0 have no place value, so you're really writing 195.8. Four significant figures. So 1, 2, 3, 4. The number after it is 0, so let's leave it as is. So 195.8. So these two answers, just in this question, would have had the same answer or same solution, right? And let me try the last one, F1 significant figure. So one significant figure is here, the number after it is more than 5, so you add 1 to the 1 to get 2. But remember, you have to put in the zeros here for the decimal point, right? Because these zeros have place values between the decimal point and a number with a place value. Right, so writing standard form of scientific notation. This is where you're writing very large or very small numbers as a number between 1 and 10, i.e. is either equal to 1 but is greater than 1 or less than 10, right? So that can be like 1 point something, 9.999, but it cannot be 10, right? So in the example, we want to write 5,123,000 in standard form. The decimal point will be after the last zero if no decimal point is given, right? And you want to write it as a number between 1 and 10. So we have to start moving the decimal point. So if you know the decimal point is here, you're going to move it. If you move it one time, it's still not a number between 1 and 10. 2 times, 3 times, 4 times, 5 times, 6 times, right? So you move the decimal pointer here, 5.123. Now, this number is vastly smaller than this number here, but we want it to be equal. So we'll multiply it by 10. So how many decimal points we move it? 6, right? And note, when we move the decimal point to the left in standard form, the power is positive. So this power would have been positive, right? Now if we move it to the right in standard form, it will be negative. So what about we have right 0.00000. So if we want to write this in standard form, you have to move the decimal point between the 1 and the 2, right? So the decimal point was here. We move it 1, 2, 3, 4, 5, 6, 7 spaces in this case. So you'll get 1.2 by 10. Now this number, 1.2, is larger than this number. So this negative sign means that you will have to divide, right? So when we move the decimal point to the right in standard form, and this is only in standard form for scientific notation, the power is negative, right? So we have a negative power there. The positive and negative powers come from laws of indices. A positive power is A by A by A. A negative power means that we're dividing by A by A by A. So this is the reason for this, right? We would learn this later on in algebra, but we're not ready for that as yet. So for now, just learn these two rules. Right? Now questions like this one come for CXC all the time, where they ask you to multiply or divide or work a question, write your example exactly, and write it to significant figures or decimal places or standard form or whatsoever, right? So anybody still writing these examples? I'm gonna give Brandon a chance to write it out. Right, number 3 is 1718.052 divided by 67.8. Right, so 1718.052 divide 67.8 equal 25.34. Right, so this is exactly. That's exactly right. B. You want the 3 significant figures. 1, 2, 3. So you're looking at the number after the 3, which is the 4. It is less than 5, so you're leaving it as alone. So 25.3. C, 1 decimal place. You're still looking at the 3. So again, you should get the same answer, 25.3. Nearest 10. The nearest 10 is the 2. So you're looking at the 5 in this case. It is greater than or equal to 5. So we add 1 to the 2 to get 3. And then I put the 0. E, standard form. Just erase all of these things here. So standard form, we'll move the decimal place one spot to the left to make it a number between 1 and 10. So we get 2.534 multiplied by 10. We went one space, so we put the value 1. It was moved to the left, so we put the positive sign. And that's the answer for that. Any questions on what we do so far? I don't want to go into fractions and decimals as yet. Right? So I want to believe I could call it a D to D. Right? So just to review, we did these values, approximation, significant figures, standard form, approximation to decimals. Right? So yeah, we could call it a D. Right? So if anybody have any questions, ask now, please.